Assalamualaikum everyone. My name is Tahi Nusrat Khan.
Hello everyone, my name is Pashmina bint Walid.
So we will do our peer project together today. So let's start. First of all, I will share the screen. Pashmina, can you see my screen?
Yes, I can.
Okay, this is for lab 1B I will explain and lab 1C Pashmina will explain. Hmm, So the program I'm demonstrating the program I'm demonstrating is titled Add and Subtract version 2. The objective of this lab is to perform 32-bit arithmetic operation using the EAX register and to observe how register and memory value change during debugging in Visual Studio 2019 using the Irvine 32 library. So this is the code. This is our code. In my file lab 1b.asm, I first included Irvine 32 include so that I can use the dumrex procedure to display register values. In the data section, I declared value 1, value 2, and value 3 as D words, and final value to store the final result. In the code section under the main procedure, uh, I move value 1 I move value 1 into EAX, and in the second one add value 2, subtract value 3, stored the result in a final value. After finally call dumps to show the register content. This simple logic helps to visualize 32-bit addition and subtraction inside the procedure. So now we will see the debugging procedure. So after building, first of all we have to build, and do start without debugging. So this is our output. Then I will close it and clean my solution, and I have to build solution and start debugging. So now I will just put a breakpoint in this line and run the code again. So you can see this one after delete this. Let's delete this one. Yeah, this is the breakpoint of our code. So I have to delete these things. And you can see, so then I start debugging by pressing F5. So the yellow arrow shows where the program is paused before execution. I have opened the register watch 1, memory 1, and deassembly, disassembly, and windows so that I can observe changes step by step. So you can see if I put my variable name here, variable 1, it's taking the variable, variable 2, variable 3, and final variable. So this is our variable. If we search the variable in the memory section with, you can see this one, and we can see our code here. We need to restart it. So this is our this line, move eax dot variable 1. This is the bytecode of our code. So now I will step through the instruction using F10. After pressing F10, after move eax, after move eax, variable 1 eax equal 10,000 h. After add eax, variable 2 eax equal 50,000 h. After sub eax, variable 3 eax equal 30,000 h. Then move final variable eax stores 30,000 h in memory. When I call wrex, the console displays all register values confirming the expected result. The memory 1 window shows that the address of final value now contains 00093 0000h, and the disassembly window lists the corresponding machine byte codes. So after this, we can observe uh, how eax, a 32-bit register, updates after every instruction. Using the watch memory and registers windows help me understand how data moves between register and memory in real time. Overall, this lab taught me how to trace 32-bit arithmetic instruction and verify them through dumbrex. Thank you so much for watching lab 1b. So now Pashmia will present the lab 1c. Pashmia, can you present?
Yeah, sure.
First of all, I have to change this one. Yeah, you can start.
Now I'm going to explain Lab 1C. This program is titled Add and Subtract version 3. The aim is to perform arithmetic on both 16-bit and 8-bit unsigned integers and to observe how the X and H registers operate within the CPU during debugging. Now, moving on to the code explanation. In my file lab1c.asm, I included arvine32.inc. Then in the data section, I declared three word variables, variable w1, variable w2, and variable w3, and a final variable w to store the 16-bit result. Three byte variables, variable b1, then variable b2, and variable b3 plus final variable b for the 8-bit result in the code section. Then I first use the AX register for the 16-bit part, then use H for the 8-bit part. After each section, I called dumprex to show the updated register values. Now, moving on to the debugging process. At first, we need to go to build, then we need to clean the solution, then we need to go to build again and then rebuild it. And after that, we need to go to debug and then start without debugging.